And I do want to thank all of you for dialing in this afternoon. The purpose for this call is to introduce a new mechanism that we're rolling out today, through which you can identify capability gaps with our measurements or data products, or opportunities to expand on existing capabilities. We've traditionally collected input regarding capability needs through meetings. The annual science meeting has been an important venue, as well as focused workshops and other settings, but particularly those where we have get formal written input. But we've often heard input from the community that there is a need to have a clearer mechanism and a mechanism outside of meetings for users to identify needs. And so we're now launching such a mechanism to collect this kind of input. In this session this afternoon, I'll provide some context for the input process, and then we'll introduce you to the process itself. The background material will include a very brief introduction to ARM. I'm sure most of you are very familiar with ARM, just a one-slide introduction. Some current activities, traditional methods for input, and those will continue to be important. An overview, short overview of the decadal vision, because this will provide both an idea of the kind of input we have received and also some context for our current priorities as we think about getting in additional input. And then once I've gone through this background, I'll discuss this new web-based mechanism for you to provide input and the associated process that we'll use to review that input. I don't expect to take close to the 90 minutes that's set aside. I'll probably take about a half an hour for my remarks, but I want to make sure that there is ample time for discussion. I suggest that you hold most of your questions until the end, but if you do need clarification at some point, please put your question in the Q&A. And then Rolanda or Michelle or one of the other panelists can let me know, and I can address that then. Otherwise, at the end of the presentation, you can use the Q&A to raise questions, have discussion, or you can also raise your hand at that time, and I'll remind you of that if you want to address the group directly. So most, if not all of you on the call are very familiar with ARM. So again, just have a one-slide introduction in case there's a few on here that are not. So ARM has been providing atmospheric measurements, supporting research and model development for nearly 30 years. These measurements are provided by about 450 instruments deployed at 6 ground-based observatories. Ground-based measurements are supplemented by aerial measurements on an episodic basis. Data from all these measurements are processed to standard formats and are made freely available through the ARM data center. Over the last 5 or 6 years, we've additionally provided simulations to link ARM observations to larger scales. And to this point, this is focused on shallow convection in Southern Great Plains, but we're looking to move beyond those to deep convection. The ARM facility currently serves about 1,000 scientists who are actively using ARM data by providing data from these measurements and hosting field campaigns at ARM observatories. Another important aspect of the ARM facility, in addition to providing these measurements, is that while we operate 24/7, so we really are a fully operational facility, in some cases provide these continuously for decades, it is a research facility, and the nature of the measurements evolves to meet the needs of the community. And so that's kind of at the heart of what we want to talk about today, this evolution and how we want to do that. Just to give a sense of some of the development activities that are going on right now, we're putting a lot of our effort. I've listed a few of the major activities currently going on to either enhance or expand or evolve our measurement capabilities. And I included there a few major field campaigns. These are underway, but they do represent a lot of effort on our part. So there are 2 mobile facility deployments that were begun this fall. The SAIL campaign began in September in New Crested Butte, Colorado. Will run through June of 2023. And Tracer began a month later in Houston and will run for 1 year. These 2 mobile facility deployments, these 2 mobile facilities are typically deployed for about a year at a time. And they have allowed us to sample locations as diverse as both the North and South Poles, to the Indian Oceans, to the Sahel region in Africa. A call for the next deployment following the SAIL mobile facility deployment will be posted in the next few weeks. So you can look at the ARM website for information about that. We also operate a third mobile facility that is deployed for longer periods of time. That observatory is operated in Licktock, Alaska, was operated for 7 years and is now transitioning to a very different set of phenomena in the southeastern United States. The observatory will have multifaceted science targets, including deep convection, aerosol processes, and land atmosphere interactions. That observatory is planned to go online in 2023. ARM operates a diverse radar network across the ground-based observatories that provide critical measurements of hydrometeors. For several years, we've been formalizing priorities for this network, and Adam Tyson has just worked with the radar team and other stakeholders to publish a technical report listing priorities for the current fiscal year, which runs through September of 2022. This report is available on the ARM website if you go to any of the ARM radar instrument pages, such as the KASER, which is the zenith pointing radar. We're also working with the radar team and stakeholders to further optimize operations of this radar network. As I mentioned a minute ago, we are transitioning this large eddy simulation modeling system from studying shallow convection in Oklahoma to looking at deep convection associated with a field campaign we did a few years ago in Argentina. And we're already beginning to prepare for the follow-on to that study, looking at marine stratocumulus over the ARM Eastern North Atlantic site, which is one of our 3 long-term observatories. We are in development mode for both our piloted and uncrewed aerial measurement platforms. We're in the process of modifying Challenger 850 to serve as the new ARM piloted aerial research platform, and that modification work will continue through 2022. And that will be followed in by a period of instrument integration and testing. Meanwhile, the mid-sized UAS uncrewed aerial system Arctic Shark has undergone modifications and acceptance, and will begin undergoing testing this year, as well as instrumentation integration and training of the staff with the goal of first science flights next year. You can see more about those platforms as those developments unfold on the ARM website and in newsletter, so please look out for that. And there's much more going on around the facility, including the development of new value-added product data streams, instrumentation upgrades, and engineering development under the hood to make data processing more efficient. But I just wanted to show you a few of the major things going on to give you a sense of some things that we're working on here in the ARM side. Now, with 450 instruments across 6 sites, serving 1,000 active users, and a consistent desire to take on more capabilities, optimizing the configuration of the facility is a challenging problem, but this is something we're always striving for. And this is the object of what we're rolling out here today. Now, collecting input is not new. As I said, we've been collecting this in a variety of forms, and just want to outline a few of those ways that we already are collecting input from the user community and will continue to do so going forward. First of all, I mentioned these mobile facility deployments, whether we're deploying an entire mobile facility or accepting a guest instrument. We conduct a number of these sorts of field campaigns each year, and those are driven by proposals from the community, and you can go to our research campaigns site on the website to learn how to propose a field campaign at an ARM site. And these deployments are followed by engagement with the principal investigator team in the planning and implementation phases. To identify measurement or data product gaps or issues, again, the Animal Science Meeting has been a very important source of input for many, many years. And breakout sessions at that meeting often point to actionable needs that are used to set priorities for the next year. Either ARM or DOE also periodically convenes workshops to solicit input on specific topics. Recent examples include a mobile facility operations workshop that DOE held a few years ago, cloud and aerosol measure workshops that we held with our constituent groups about 2 years ago, look at LASSO priorities, which led to this focus on deep convection and marine stratocumulus, and an aerial measurement workshop which is feeding into how we're going to outfit the Challenger aircraft once that is modified. All these workshops and many others that we've conducted are extremely valuable for soliciting input from the community. And again, we'll continue to be doing that going forward. Over the past 5 or 6 years, we've also been engaging with standing constituent groups. We have a user executive committee, we've got cloud and aerosol focus groups, and we've had ad hoc groups at times, for example, to advise on uncrewed aerial measurements, and we'll likely do that again in the future. But these also provide very useful input as we consider options and try to understand where we're might be needs to make adjustments. Now, and these are all somewhat informal to various degrees, but every 3 years approximately, DOE also convenes a more formal review of the facility and all user facilities, not just the ARM facility, to assess how we are serving the community. This is another important source of input, feedback to ARM to help us know where we need to be developing capabilities. ARM had our last review at the end of 2020. Recommendations from that review included a call to enhance outreach to the modeling and satellite communities, a call to refine our radar operations plan, and I talked about that a little bit earlier, continue to explore opportunities to expand data products and services, and some specific examples were called out in those recommendations, such as visualization of data, for example, and instrument simulators to support models. Also, to implement a process to review existing capabilities to make resources available for new capabilities. As we have been under relatively flat funding scenario, we cannot continue to add new capabilities without at some point taking things away. So we've been called upon to have a process to manage that, that balance. Now, before I get on with new capabilities, I do want to briefly talk about this issue of looking at old ones, because this is, again, a balance that we need to always strive for. So this is one of the actions called out by the last year's review, and it's something that had been called out for some time. It's just really underlined in this last review. And the intent is to identify facility components that are having less of a science impact than other areas, or at least in relation to the resources that we're spending on that area. And so these are areas that need to be considered for adjustment. One area that comes to the fore are our radar network. These take a significant amount of resources. They are very important to our science, to our users, and we will continue to support them. But we are undergoing a review of how to balance these so that we can operate them in a sustainable way and ensure that we are delivering quality products to you in proportion to the effort that we're putting into those. And Jennifer Comstock has been leading a group over the last 6 months or so, looking at the scanning cloud radars in particular, and we'll soon be coming up with some recommendations for how to manage that network. At that point, we will develop a strawman plan for how to do that. We'll likely be seeking input on that plan and then proceed to develop this balance. Next thing that we're looking at, planning to look at, is shortwave spectrometry. These instruments have had some issues over the years, and there's not been a great deal of supported research for these instruments. So we're looking at how to, what are the goals for these instruments? How can we make best use of those instruments? In general, going forward, what we'll do again is look at, where do we have imbalance in resources provided to an area relative to the science impact that an instrument is having, or are there operational issues with an instrument? And then that will lead us to do this review to develop some plan. Again, the goal is to free up resources so that we can take on new capabilities. So I would like to now turn to that other side, more pleasant to talk about, taking on developing new capabilities. And one last thing I want to do before getting to the solicitation of input, I would like to say a few words about one more topic, and that is the recently published ARM Decadal Vision. So this represents a lot of our current priorities, where we see the facility going over the next 5 to 10 years. The Decadal Vision is based on community input, and we've received input in a number of areas related to measurement gaps, the need to create better links between our measurements to models we are intended to support, and also to improve the characterization of our measurements, which underlies everything we do. We received input in these and other areas and created this updated Decadal Vision, which was published earlier this year. The document is organized around 4 main themes: measurements, data analysis, data services, and linking observations to models. These themes encompass the body of input that we had received in the years preceding the publication of this document. In some cases, the document identifies very specific activities like the move to the Southeast United States, but in most cases, the document describes higher level needs and aspirations. The areas are also built on each other, beginning with providing the most impactful set of measurements, applying then the effort to characterize those measurements, making them optimally useful to the community, continuing to develop computational infrastructure to facilitate this characterization, as well as engagement by the science community, and then linking these observations to models. I will take a brief look at each of these areas, and then I will get on with this new process for soliciting further input. I'll begin with measurements. The vision document captures 2 major development activities that are already underway: the move to the Southeast United States and the development of the Challenger aircraft. These activities represent a significant effort over the next few years and represent significant new capabilities. There was a section capturing examples of measurement needs that have been identified, and there are a number of these listed, both in aerosol, cloud, and related areas. This is an area where we clearly need further engagement with the user community to identify the areas that will have the greatest impact, because we obviously do not have the capacity to do all of the things that might be of interest. So we will be eager to get input from you and then make plans around those prioritized input. I also heard need to be more deliberate about coordinating intensive periods at ARM observatories, particularly with the aerosol community, but I could easily see this applying to other parts of our measurement system as well. And we expect this to be an early activity, this coordinated intensive periods. Although it was already set in motion before the Decadal Vision, I would consider the Tracer campaign to be an example of how this can work, as was Go Amazon before it. In both cases, we're seeing a large number of investigators coordinating around an ARM activity. But following Tracer, we will identify further opportunities to solicit joint intensive activities with the user community. And then there's also the critical issue of linking what are largely point measurements at ARM sites to larger scales. This was a focus of the 2014 Decadal Vision document and led to activities such as the large eddy simulation modeling framework, the implementation of stereo cameras at Southern Great Plains, also at the Cacti Field Campaign, expanded use of uncrewed aerial systems and tethered balloon systems, and has been part of the design of the Southeast United States Observatory. But there are more opportunities, both in how we deploy our instruments and also how we engage with other networks. So we're interested in engaging with you regarding development of strategies to further create this scale link. The next area is data analytics. We devote a lot of effort to characterizing our measurements through our instrument mentors who manage the operation, calibration, assessment of our instruments, the Data Quality Office, who has overall oversight of ARM data quality, data product translators, and really all of our staff. But again, with 450 instruments and over 2,000 active data streams, there's more that can be done. And this is a message that we hear from our users. The first thing is so simple that perhaps it doesn't need mentioning, but I think it is important to call out and does require deliberate decisions on how we use our resources. And that is simply providing the opportunity for ARM staff to spend more time in the data, from detailed quality assessment to the demonstration of applications on their own, as well as in collaboration with the user community. Doing this is going to require finding the appropriate balance between operation of instruments in the field and managing the data at home. It's a balance we're going to have to explore internally and also with you. As with all these areas, I'm interested in pursuing discussions on how to achieve this most effective balance. Now, while the first step here seems simple, spending more time in the data, with so many data streams, this is not going to be sufficient. It's ultimately going to be self-limiting. So we have to find more ways of efficiently getting through the data. And this points to the importance of leveraging new tools that are emerging, such as the ability to identify patterns through machine learning to increase the level of automation in dealing with these data. There's the DOE workshop going on right now, AI for ESP, to study artificial intelligence applications. And ARM is in a great position to leverage the techniques coming out of this field to improve the characterization of data quality. But it really need to go back to building on a foundation of really spending time in the data. Now, as of yesterday, according to our data center dashboard, we were just a few terabytes and a few weeks of radar data spectra short of 3 petabytes. Counted 2988 terabytes. Considering the number and diversity of data streams we are managing, achieving these advances in data characterization, as well as enabling you to make optimum use of our measurements, will require a significant investment in data services. This begins with ensuring that we have adequate computational hardware. We have made significant investments in high-performance computing hardware in our site data systems and data storage, but we will continue to monitor needs in these areas. And we've been charged with assessing on an ongoing basis, finding the appropriate balance between maintaining internal computing capabilities and cloud capabilities. So that's something we'll be looking at going forward. But of course, the hardware is not enough. The proliferation of data requires appropriate software tools as well. As an example, the output from the deep convection lasso, this large eddy simulation model, cases is expected to exceed a petabyte on its own. So there's a clear need for tools for data searching, for visualization, subsetting of data, and analysis. We'll be developing ideas and engaging with the community to identify how to best apply our resource to develop tools that are of greatest use to you. And we hope and expect that to do this in an open source environment, so the capabilities that we develop can be applied broadly, and also such that we can leverage software that is being developed in the user community. There's a great deal to do, and we want to share the development load as much as possible, as well as would like to be transparent in our data processing. And the final area is linking to models. The other 3 areas all contribute to impacting model development, but given differences in scale between ARM observations and models and in differences in the science communities, we know that we need to take additional steps to make ARM data optimally useful to model evaluation and development. We're doing a lot in this area, and the first 2 bullets here really represent a desire to expand on the work we are doing to provide model appropriate data sets and to leverage modeling frameworks such as lasso, skill column models, and regionally refined grid models to link ARM observations to larger scales. The key to this really lies in the 3rd bullet, and that is to strengthen outreach to the modeling community to identify opportunities for direct engagement. To be truly successful at the application of these methods, we need to be closely engaged and identify very specific projects where we can work together to mutual benefit. And we've seen this play out in the past, and we'll be working in the coming years to continue to identify these cases. And this would really be at the heart of our the outreach that we've been encouraged to do in our last review. To some extent, I expect conversations along these lines to come up in any discussion we have about priority. But I know that we've be more deliberate about specific activities to reach out to the modeling community. We're looking at ways to do that now through discussion through our constituent groups, but also welcome ideas from you on how to engage with the community. Okay, so now this brings me to the end of the background material that I wanted to provide as context for what we're is currently going on in ARM, things that we're considering priorities, things we're working towards, and also help to provide some context for where we might specifically be looking for input. But we want to understand how ARM can have the greatest science impact. We want to hear from you regarding opportunities to achieve that. Also want to be clear that we will not be able to take on all requests. Of course, we have constraints. We will need to review any requests that come in as we do now and assess how they fit in with our current framework and understand the impact that the requests are likely to have. A way to think about and implement this, this structure came up through a series of discussions with one of our constituent groups, the Cloud and Precipitation or Constituent Group, or CPMSG. And the Cloud Constituent Group proposed that we should implement a mechanism to collect input and to publicly share the list of what we're taking on and also what we're considering taking away. The group assembled a list of information that we should collect as we engage with the community on this input. And subsequently to that discussion within ARM, we have developed a process to collect that information and review that. I've outlined that process here, and I'll go through it in more detail in the next few slides. The process involves first collecting input through a publicly available forum, refining that input through a discussion forum, much like what we've done in a meeting setting. When somebody puts out an idea at a workshop or at the science team meeting, there's generally a give and take on that, and we'd like to try to replicate that process here. Then, having refined the input, we would assess that input in terms of science impact, feasibility, cost, and alignment with ARM and DOE mission. At that point, we would determine priorities and what is possible to do in the context of other ARM activities. To make room for expected high impact activity, we may need to look at reducing effort or capabilities in another area to make room for that new activity. We would then develop an implementation plan during which period we would solicit input from stakeholders, including, of course, the people submitting the request, as well as people in ARM that would be affected by the change, and that would be implementing the change. And then communicating outcomes, including what we plan to take on and what was accomplished. Digging into this a little deeper, I'm showing here the categories that were developed along the top row here by the Cloud Precipitation Constituent Group. And I've included an example that was developed by that group related to looking at vertical motion and microphysical properties in convection to illustrate what these categories are about. The problem and roadblock area states that the issue that has to be addressed in general terms, while the research element area drills down to the specific elements of the problem that are being proposed to be addressed. So here, for example, retrievals of vertical velocity and radar retrievals of different parameters. The impact should identify not just the science impact, but also the community that will be impacted. That is, I think, not called out in this case, but we will be specifically asking you what community you are speaking for and when you make your recommendation. Typically, a development project would not impact just a single project or user, but a broader community. And so we will be looking for that connection here. The solution and recommendation then calls out, requests as much detail as practical to point out how we would address this issue. So we're not just looking for you to say, here's a problem to be solved, but here's a problem to be solved, and these are steps that you can take to solve that problem. Because ultimately we're looking for actionable areas here. We can, of course, have discussions about how to solve issues, but really going after here actionable tasks. And towards that end, this maturity and readiness is meant to address how mature is the technology to go after this area, the retrievals, the measurement technology, alignment with what ARM is currently doing, to help us understand where the literature capabilities are to go after this. We want to understand our likelihood of success in going after this problem. And finally, we asked for the link to modeling because ultimately this is ARM's mission to advance modeling capabilities, so we understand how this links to that potential. And there may well not be a link in all cases. There won't be, and that is certainly fine in some areas. But please, where it makes sense, to help us understand that link. So I want to give a big shout out to the communications team and to Sarah Merrill and Brad Perkins, who have got this forum up and going for you. So this is now live on the ARM website at this address, and will soon be linked from the future directions part of the ARM website. But we now have this live forum, which has the mechanism to collect input on these areas that I've just outlined. This forum will be posted all of the time, just like the field campaign request form is now. And we plan to post reminders about this process several times a year in the ARM newsletter and on the website to kind of get people thinking about this, so that this opportunity is available to them. Again, I want to remind you that the input should represent a community, and so we call out requests for that, as well as providing guidance in other areas for the kind of information that we're looking for. To help understand the community interest in an activity and to further refine submitted ideas, we do plan to use an online discussion forum, which would approximate the discussion that occurs at a workshop. And upon submission, I and several others are alerted to begin a review and refinement discussion process. The discussion forum is not yet set up for these capability requests, but ARM has set up a discussion forum, and thanks to the LASSO modeling team for piloting this for us. They've recently implemented this for discussion of the deep convection cases, and that is available at the discourse adc.arm.gov, and that will be soon linked as well from the capabilities future directions page once we have some requests to discuss. But this forum will allow us to discuss and refine requests as they come in a public way, again, simulating the discussion that goes on at a workshop. And we anticipate that this will help us to really get to actionable tasks. Once the input has been collected, discussed, and refined, it will be assessed according to the provided elements, as well as with alignment with the DOE mission and goals. For example, the topics in the ARM decadal vision or the EESSD strategic plan. I'm expecting that we will review materials on an annual basis to support our annual budget planning activity. I don't think practical that we would do it at a finer temporal resolution than that, since we're really setting our development activities on that temporal scale. And this is consistent with how we currently use input from the ARM ASR meeting and other workshops in our annual planning. So typically we take input that we receive in the fall and the spring and into the summer to create our plans as we go into the fall planning season. And again, I mentioned this before, but we will continue to use all of these other sources of input. So this will represent another stream, but one that is hopefully more clear to those who would not have the opportunity to get to some of these meetings. Now, once an activity has been identified as a priority, we're still not quite done, because at that point we will need to develop a formal design and a project plan around that intended activity. This is something we do within ARM all of the time, but this is something we would do more in conjunction with the user community. And it is possible at this stage, once we go through a formal design, we may realize that the idea is not as mature as we originally thought, or that the expense is beyond what we expected, but that is really the purpose of this design phase. But the goal is to develop an achievable plan and then implement, trigger the start of that plan. And then at that point, we would, during this process, we would engage a variety of stakeholders, including representatives of the group seeking the new capability, as well as those doing the work and those who might be impacted by this new capability. Assuming this is approved and that we have the appropriate resources, at that point we would initiate the project, and we would then post this on the ARM website under the Future Directions page. And actually, if you go to the Future Directions page now, I don't know how many of you have checked that area out, but we do already point to some of the currently active development projects there, and we'll be adding these to that area. So drawing to a close here, I just wanted to finish by reminding you of a few key points. We're implementing a mechanism to collect input regarding capability needs from the community outside of the usual mechanisms, such as workshops and the annual science meeting. Those other mechanisms will continue to be used. We are looking for capabilities that will have a significant and preferably broad science impact. Activities also need to be aligned with ARM's mission, and of course, need to be achievable. We hope to use community discussion to help us understand these requests and refine those requests. And also a reminder that we do have a parallel activity to remove capabilities that are not having an impact, to make room for new capabilities to achieve a balance towards the optimization of ARM service to the advanced science. So with that, I will end and look forward to any discussion here. If you've got questions, you can use, again, the Q&A feature in Zoom, or you can use the raise your hand feature, and then one of our panelists will unmute you and you can ask the group. So I'm going to stop sharing and we can have a conversation.
Hi, Jim. We did have a question in the chat about can anyone see any of the requests that are made? So if you want to clarify that.
Well, I want to be a little careful there because I don't know what might come in. So I think any reasonable requests we would intend to post in this forum. So that would, so the way that I'm envisioning doing this is when a request comes in, that would go into this discussion forum, and that's where that would be seen. I'm imagining that there could be requests that could be a bit more off the wall, and reserve some judgment to filter those. But my intent is any reasonable request would be viewable.
And then Gary also had a clarification for us on there is over 3 petabytes of data publicly available when you combine the PI data and the IOP data.
Aha.
So we are over 3 petabytes.
Thank you, Gary.
Do we have any other questions?
Well, perfectly clear.
So we have a question of, can you expand on data processing, analytics capabilities, and machine learning regarding PI deployed instruments and data with ARM data? Can a PI request help with getting started with AI or machine learning?
Well, I would say that we are not to that point yet. So I think ARM we're at the stage of looking at how can we apply AI ML to our own measurements. Now, I think if you have, so ARM is not in a position of training PIs to how to use AI ML. We'd be very interested in ideas that the community might have to apply AI ML, particularly towards our measurements or possibly also PI measurements. I guess the way I would like to see this play out is that we would develop this expertise so that we could do what is being requested here and pass that expertise along. We have done some experimentation already. We've had some pilot projects over the last few years in feature identification and quality assessment, and actually have machine learning applied to one of our value-added products. So we're looking to advance this along. And so I think I would say that it is a goal to be able to do what's being asked there, but we're not in a position to do that now.
We have another question in the chat. Is ARM going to provide funds to support joint projects with the modeling community?
At this stage, the way I would see this, Xiaoshing, is that I would like to see us have grassroots discussion to identify the opportunities there and then socialize those opportunities with DOE. I mean, ARM does not currently have funds allocated to support such an activity, but my hope is that once identified, we would be able to look at ways of working with DOE to funding some of these activities. So obviously, to be truly successful, there will need to be some support somewhere, but I think the way I see this is a discussion. ARM is in a position to enable discussion between the modeling and the observation community.
It feels like everybody's quiet today.
Any update on the ARM aerial facility? Not so much beyond what so the Challenger is undergoing modifications and that process is ongoing, and that's expected to go on well into 2022. The Arctic Shark underwent a series of modifications and tests back in the summer, and that all went well. And so currently planning on training for that capability and towards flights next year. So as I mentioned before, we're looking at developing these two platforms to support in the not too distant future. Of course, we also, it's sort of between ground-based and aerial capabilities, but we also have the tether balloon systems that we fly. And so we're planning to fly the tether balloon at Sail coming up here. There's some missions planned for Southern Great Plains in the coming year, and we'll be doing another joint call with EMSL in the coming year as well. So looking forward to that.
So Jim, what are the priorities regarding the ENA site, and are there any plans to expand it and characterize the ocean surface properties from Veranda?
There are no such plans. We have put that out there with the cloud precipitation group as a topic that we think there's discussion and engagement with the community to look at what should be the next steps for that observatory. How can we, of course, we're taking on the LASSO simulations following the deep convection, but in terms of measurements, how can we best move ahead warm cloud measurements at ENA? And so that's something we'd like to have a discussion. And I would say you could ask the same question about Upyakvik and what we want to do with cold clouds up in the North Slope. So similarly, would like to have a discussion around that site. You're welcome, Verenda. And I guess I'll just, add, this is this mechanism they're rolling out is intended to be egalitarian, that anyone can make use of it, but I really do want to see the broad impact. So I would strongly encourage, much as you would if you were going to seek a major field campaign, to seek out a community and look for, how would this be of broad use. That could be done in the context of the ASR working groups, the cloud or aerosol constituent groups, or the user executive committee, or with other communities, for example, satellite science teams, modeling science teams. So would definitely encourage you to look to whatever communities you are a part of to understand what are broad needs that that we can help fulfill as you think about these gaps. And I know something that Rolanda's been and her team have been providing some of this guidance on the forum. But as you are thinking as well, make sure that you're thinking about what we already are providing in terms of measurements and data streams. Because there's a lot of information out there on the website. Also note that if you're not sure whether we're providing something or have questions like the ones here, there is in the bottom of every ARM web page an Ask Us button that you can reach out and get information about a topic.
So Xiaoshing asks, are you encouraging ARM translator group to consider using AI and machine learning in their VAP developments?
I am. I think that's important. I think the mentors as well. I mean, really, the second theme in the decadal vision is really aimed at both the user community, but particularly at ARM staff, and both together, but it definitely look to the translators and the mentors and our data services team to work together to see how can we go after these data characterization problems. And I think that, and this may be my my perspective, but I think looking first at what are the problems we're trying to solve, understanding the data, and then looking to the machine learning to how they can solve those problems is the way I like to see that approached, versus asking how can this tool help us. But I do think that there's a lot of promise in these tools, and I think ultimately there are tasks that we will not be able to accomplish any other way. There's just so much information. So Xiaoshing, maybe that's something you can discuss in your translator workshop early next year.
Xiaoshing says, yes, they will. So we have another question. When is it expected there will be a process for filter sample requests joint with improved network?
Improved networks, that's interesting. So I've not thought about that. So we have actually been talking just recently, Adam Tyson, who, if you don't know Adam, he's our instrument guru, is in charge of all of our instrument team. And he's been looking at the question of how we can consistently manage our own filter samples. So we do currently collect filters for ice nucleating particles, and Jesse Creamian and Tom Hill lead that work. We collect it on our tethered balloons, and that's in conjunction with EMSL, as well as we have our own filter samplers. And we've had some PI instruments. Now, the Improve instrument is really not our own. That is an instrument deployed by the Park Service. So I would need to work with the Park Service to understand what that possibility is. But I will ask that question because it's connected to this broader effort of how to make these filters available. Please.
Would you like me to read it, Jim?
Yeah, it is an important, vertical velocity is an important variable for understanding dynamical processes such as convective momentum transport and organized cloud systems. We will also need to measure cloud scale pressure gradient for the cloud systems. Can ARM add this variable to the list? So this, we are having discussions right now in the cloud precipitation group, and that is a topic that came up in that group. I mean, it's been coming up for at least a decade now, and there has been vertical velocity, I think, is the measurement of vertical velocity is the variable in question. And I guess maybe Jennifer's asking if more specificity, but okay, let's just repeat the last one. Yeah, so the bottom line is this has been identified as a key variable of need, and there has been work done on that. There's been some development of products in this area, but there is interest in doing more. So Christopher Williams in the cloud precipitation group has indicated interest in looking at this, and he's done some work there. So I am expecting that there will be exploration of what ARM can reasonably do in this area. But I think we're definitely in the early stages of considering what might be practical. But I think this would be a good example. You know, if there were a proposal to take this on, we would really want to refine specifically what is it that we're going after, because this is such, I mean, vertical velocity is such a broad idea, whether you're talking about in cloud, out of cloud, deep convection, on what spatial scale, you know, the answer to those kind of questions will dictate how achievable this is.
I would say, any last questions for Jim? We're getting close to the end of the hour.
Okay, so question in the Q&A, you mentioned data characterization in the data analytics. Does it include case or regime categorizations, including AI, ML, processed by ARM? I mean, I think that is an important area. I mean, I'm imagining, what are the distributions of measurements under a variety of conditions. I think that understanding that would be important, and really preceding the AI ML, understanding those distributions, understanding the normal behavior of data, and then using the AI ML to apply that information and to deepen our understanding of that. So again, I open to any suggestions on how we go after this, but the goal should be to identify areas where there is a lack of understanding of the characteristics of certain measurements, and then to improve and deepen that understanding. And if AI ML is a part of that, I think ultimately will likely be in various places. But I think the first thing maybe is to identify areas where this is a need, and then start to identify opportunities to address that, with the goal of improving the characterization of all of our measurements for the user community. Really look forward to this being a collaboration between the instrument team, the translators, and the science community. Okay. If there are no other questions, it might be a good place to call it, but I think there will be a survey at the end where you can provide input on whether this was useful, what you would have liked to have seen, if there's something else you would have liked to see. I think you can also provide information there if there's some kind of question, but again, you can also use the Ask Us interface if you have a question later on. And would encourage you to check out the new interface and let us know if you have any questions or comments about that. I'm sure that will evolve a bit over time.
I did drop the link to the form in the everyone chat. So.
Okay, well, I do want to thank you all again for participating. I hope it was informative, and I hope that this will prove to be a useful mechanism, another useful mechanism for engaging with you as we work on identifying our priorities. I think we're always trying to improve how we do that. So thank you for your attention. Another question. Can you please provide a short review of this session? So Heist, do you mean, so Heist is asking if I can provide a short overview of this session. Do you mean a video, or just provide the slides, or like a one-pager? Could you clarify, Heist, what you were looking for? Yes to the above.
Okay. We also will probably have this recorded on
right.
YouTube.
Yeah, so that's right. It is a recording, so that will be available. Of course, it is an hour. So to Heist's point, we'll perhaps have I'll talk to Rolanda about it when we get together. Either have a short write-up. Okay, yeah, short write-up. That sounds good. Yeah, we can definitely do that.
Yes, we can probably get Heist a blurb, and all the working group chairs a blurb to share in their newsletters.
Okay.
We have another question from, do you want to mention DOE's cluster for AI work?
Cluster for AI work.
Do we mean
I
cumulative?
assume the question means the cluster that we have that could be applied for AI work. I assume that that's what Christine is talking about. So yeah, we do have high performance computing capabilities at the data center. And I should note that that those resources are available for community use through an application process. If you go to the capabilities, I believe it's under the capabilities tab. Is that right, Rolanda?
Yes, we do have some information on the modeling and also work with ARM. And Gary sent us a message that we have some nodes that we are preparing for AI related work within ARM as part of Cumulus 2.
So if you're not, so Cumulus was our the high performance computing system that we implemented primarily for the large eddy simulation. We are now have upgraded that and are continuing to upgrade that over the next few months. And this will also, a portion of this Cumulus 2 will take the place of our Stratus system. But again, this is available for community engagement. Christine wants to say that the team there is great and super helpful. So a plug for the HPC team at the data center. Thank you. And I should say, I'm certainly in no rush to get off, so I'm very happy to answer questions. We allocated 90 minutes, so I'm happy to take any other questions, but just kind of go to the.
Oh, Eduardo has a question for you.
Yeah, it's a question from Eduardo, who oversees our site operations guys at ENA. Hello, Eduardo. Been a long time since I got to see you. He asks, is there any intention to implement the characterization of DMS flows at ENA, which so as I believe that that's referring to the very, very small scale flows. There are no such plans. The LASSO system will be working on simulating the so-called ACE ENA field campaign of a few years ago when we flew the G1 aircraft over that site for a month in the summer and a month in the winter seasons. I don't know. I think that the LASSO team is still working through what the characteristics of those simulations will do. I'm sure it will not be at DMS scales, which I believe is getting down in the sub-meter range, if I'm right on that. But it will certainly be at finer resolution than we used at the Southern Great Plains simulations. So it will be a very memory intensive. I don't think we could handle the DMS, although Bill Gustafson might be interested in taking on that question. I will say that before too long, I would expect that discussion forum for LASSO will likely open up discussion about ENA. So if there are questions about spatial scale and other aspects of those, that would be a forum to raise those points. We'll call it, but thank you once again for your participation and look forward to hearing from you in various forums coming up.